Hello people and welcome to this video. In this video we'll be working on the grade 12 mathematics paper 2 and this is from November 2022. The marks allocated is 150 marks and the time is 3 hours. Okay, so looking at the instructions, just ensure that you round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1 says, the metric class of a certain high school had to vote for the chairperson of the RCL, Representative Council of Learners. The scatter plot below shows the IQ, intelligence coefficient, of the 10 learners who received the most votes and the number of votes that they received. So we have a scatter plot first that looks at the IQ versus the number of votes. And then they tell us that before the election, the popularity of each of these 10 learners was established and a popularity score out of 100 was assigned to each. The popularity score and the number of votes of the same 10 learners who received the most votes are shown in the table below. And question 1.1.1 wants us to calculate the mean number of votes that these 10 learners received. Okay, now we can see that the votes are already here. We can see them down. So let's go ahead and put down this information, but we're going to put down the popularity score and the number of votes. As we keep going down the questions, 1.3 asks for the equation of the least squares regression line for the data in the table. Okay, so on your calculator, you can go ahead and press mode, and then you go for the option 2 that says stat. And then when you go for stat, you're going to see that option 2 says a plus bx, because that is for a bivariate data set. So we're going to go for that. You can go ahead and put down your x values and your y values. And once you've input your data, you can press AC, Shift, and 1. And then you'll see 6 options pop up, and you need to go for the option that says VAR. So we're going to go for variable. And in variable, we're specifically looking for the mean of the votes. And you can see that the votes are the y values. So we're looking for the mean of the y values. So make sure you go for the option that says the mean of the y values. So that mean is 15.5. So there we go. 15.5 is our mean. And moving on to the next question. Question 1.1.2 asks us to calculate the standard deviation of the number of votes that these 10 learners received. So on your calculator, you can go ahead and press AC, but it's not really necessary. You can just press Shift and 1. And again, you're going to see the same options pop up. And you need to go for VAR. Okay, so once you are by variable, we're looking for the standard deviation of the votes, which is the standard deviation of the y values. And so that is going to look like that. So standard deviation of the y values is equal to, and we get 4 points, and that rounds up to 59. And that is our answer. Question 1.2 says, the learners who receive fewer votes than 1 standard deviation below the mean. So it needs to be fewer than 1 standard deviation below the mean, that they were not invited for an interview. How many learners were invited? So we first have to find out what 1 standard deviation below the mean looks like. So it's a standard deviation below the mean. So if this is the mean, we're going to go a standard deviation less than the mean. So that is mean minus standard deviation. We know our mean is 15.5 and this is our standard deviation. So we're just going to say 15.5 minus 4.59. Okay, and let's find out what that gives us. And that will give us 10.91. And now we're going to look for the votes that are fewer than 1 standard deviation below the mean. This is a standard deviation below the mean. So let's look for the votes that were fewer than this. Well, technically, they said the learners who received fewer votes that they weren't invited, and they want to know how many learners were invited. So if the learners who got fewer than this were not invited, then everybody who was invited was learners who got more than this. So you could also look at it like that. Okay, so 10.91. Fewer than 10.91, we know that there are a total of 10 votes because 10 learners. Okay, numbers less than 10.91 is 9, 10, and then that is it. It's only 2 votes that were fewer than this. So it means that 2 learners were not invited, meaning 8 learners were. Okay, so you can tell them that this concludes that we could just say 10 minus 2 is equal to 8. Therefore, 8 learners were invited. Okay, and that is our answer. Question 1.3 says determine the equation of the least squares regression line for the data given in the table. Okay, so we know that the least squares regression line looks like this. Y equals A plus BX. Okay, it's the equation of a straight line. And so we just need to find the value of A and the value of B. So on our calculator, we're going to go ahead and press Shift 1, and then it pulls up the information where we can see variable, but this time we're not going to go for variable. We're going to go for the option 5, which says REG, and that's for regression. And then when we go for that option, you can see the value of A and B. So A is simply 1 point, and that is going to round up to 2 decimal places, so it rounds down to 77. And then you can find the value of B. Again, press Shift 1, and then go for regression, and then option B, which is 0.22, rounded off to 2 decimal places as well. So the equation of the least squares regression line is simply 1.77 plus 0.22x, and that is our answer. Question 1.4 says, predict the number of votes that a learner with a popularity score of 72 will receive. This is a popularity score. Now, we can see that from our data, the popularity scores are the x values. So they've given us an x value and they require us to find a y value. And since we have the equation of the least squares regression line, this is what we're going to use to make any predictions. So the popularity score, this is an x value. And so we're saying y equals 1.77 plus 0.22. And in place of x, we put down a popularity score of 72. Okay, let's find out what this is. You can still do calculations on your calculator. So this is equal to 17.61. Okay, and I'm just going to leave the answer like that. And that is our answer. Question 1.5 says, using the scatter plot and the table above, provide a reason why 1.5.1 IQ is not a good indicator of the number of votes that a learner could receive. Okay, so let's go ahead and see where we had IQ indicated. So that was in the scatter plot. Okay, so just notice that whenever they ask about good indicators, whether something is a good indicator or not, they're usually referring to the correlation. Okay, now the correlation can be seen using that value R, or it can be assumed using the way the scatter plot looks. Now, where we have the IQ is in the scatter plot. Do you see how these data points look? They're all just scattered around. This one is over here, that one is over there. There's no consistency at all. If there was some sort of trend where they're kind of like together and moving in one direction, then you'll see that there is actually a consistency here. We can actually say IQ is a good indicator for the number of votes that a learner will receive, but there's absolutely no correlation because they are scattered across. There's no consistency. Okay, so we'll just have to word that, and that would be our conclusion. Okay, so my conclusion on this is the data points are scattered and do not consistently follow a trend. This suggests a low or no correlation, and that is our answer. Question 1.5.2 says we need to, okay, again, using the scatter plot and the table above, provide a reason why the prediction in question 1.4 is reliable. So let's look at 1.4. Okay, so 1.4 was about that popularity score. Why is this reliable? Why can we say it is reliable that somebody with a popularity score of 72 is likely to get about 18 votes, right? So why is that reliable? Well, we're going to have to look at where this data came from. This was from the table. That's where we got the least squares regression line. Okay, when they speak about how reliable the data set is, you're going to look at the correlation. Now, in this case, because we actually had values, we can find the correlation coefficient. Okay, so let's go ahead and find the correlation coefficient using our table. So I'm just going to have to remove all of that. If not, it will multiply. So on your calculator, press Shift and 1, and then make sure you go to regression. Then correlation coefficient, look at what that is, 0.98. This is a very strong positive correlation. Okay, so this is why it is reliable. So we can conclude that 0.98 is a very strong correlation. You don't really need to include that it's positive. You can. The positive just tells you the direction of your data, whether it's increasing or decreasing. Okay, this is a very strong positive correlation, and that is it for this question. Question 2 says, a company conducted research among its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the Ogive, the cumulative frequency graph below. Okay, so this is our data represented. And question 2.1 says, how many people are employed at this company? Okay, so the thing about the cumulative frequency graph is that it is made by adding the frequencies in each class. So when you keep adding the frequencies, that is why these keep increasing, that cumulative frequency. When you get to the end, that last point that we have will show you the total frequency. And the total frequency would be the total number of people, or the total number of data points that we have in the study. In this case, it's people. So that would be a total of 60 people. So there are 60 employees in this company. Okay, 60 people employed. Moving on to the next question. Question 2.2 says, write down the modal class of the data. So the modal class, this is the mode, but the thing is our data has been recorded in classes, okay, in groups. So the mode is the number or the value that appears the most. In this case, the mode would be looked at as the class with the highest frequency, because the frequency tells you how many of that class you have. So we can see that the maximum spent was about 35%, okay, on fuel. So this is how we can look at this. You see, from 5 to 10, this is a class of its own. And for us to find out, so we can say x is greater than 5, but less than or equal to 10, since the maximum is exactly at 35. So to find that frequency, here is what we do. We would take this, right, whatever this is, and you subtract it by the previous frequency of that data point. The reason why is because these are cumulative frequencies. They've been added. They are added frequencies. So looking at this, this is 0. This is roughly about 5. So that will be 5, right? And then looking at this, so it means that between where x is greater than 5 but less than or equal to 10, you have a frequency of about 5. Remember, we're looking for the highest frequency. And then in this scenario over here, you would take that, which looks to be about 12, right? Minus the previous frequency, which was about, this was a 5-ish. So that would be like a frequency of 7, okay? And so on. So where you'll find the highest frequency is where you're going to notice the biggest jump between your data points. You see that between this and this, it's not that big of a jump. Between this and the next jump, not that big. But look at these two. Look at that. That would be the biggest jump. So this is where we will find that frequency. Notice how to find the frequency of this class where x is greater than 5 but less than or equal to 10. We knew to look at this point. We said that frequency minus this frequency. So to find that biggest jump, that highest frequency, it's going to lie here between these two data points. And so that is where x is greater than 20 but less than or equal to 25. Okay, and that would be our modal class. The biggest frequency lies here where x is greater than 20 but less than or equal to 25. And that is our answer. Question 2.3 says, how many employees spent more than 22.5% of their monthly salary on fuel? Okay, so let's look at this data. 22.5, we're just going to have to find out exactly where that is first. Okay, so from the way these are moving, they are going from 0 to 5. Then there's a middle here and then 10. So the middle of 5 and 10 would be 7.5. and then that would be 12.5. Okay, so they're moving in 2.5 in intervals of 2.5. Okay, so 22.5 would be here. This is 22.5. And we're looking for the employees who spent more than 22.5. So here's how we find them. We go to 22.5% and we run up to the ogive. And once we hit the ogive, and you just have to try to make it as accurate as possible. Once you hit the ogive, it looks about here, we're going to run to the left and then see what number this is. These ones are counting in 2, so that's 30, 32, 34. So here's how we find the people who spent more than 22.5%. Everybody from 34 to lower than this, they spent exactly 22.5 or less than 22.5. Everybody above spent more than 22.5. Okay, so that's thereby after 34. Okay, these are the people who spent more than that. So how we find them is we know that there's a maximum of 60 employees. So we'll say the people who spent more than this because they start from above 34, this will be 60 minus 34. And then we'll find out that number. So 60 minus 34 is equal to 26. So it's 26 employees that spent more than 22.5% of their salary on fuel. And that is our answer. Question 2.4 says, an employee spends 2,400 Rand of his salary on fuel in that particular month. Determine the monthly salary, okay, what is total salary, of this employee if he spends 7% of his salary on fuel. So this is the money he spent on fuel. This is the percentage. So they're telling us that 2,400 Rand represents 7% of his salary. So this represents 7%. Okay, here is how we can find out the total salary. You know that we're saying 7%, meaning 7 out of 100. That is 7 over the total salary. So 7 over 100. And so we are saying that this is equal to 2,400 over whatever his total salary is. And this is really what this looks like. Okay, so if you transpose the x and then take that over, what you're going to end up getting is, see, if you take this out of the denominator, it's going to move to the numerator. If you move this over, the numerator and denominator will just switch places because you're really just dividing both hand sides by this number, okay? And if you're dividing by a fraction, you're going to use tip and times, meaning whatever this is, and then you're going to tip and times, meaning multiply by 100 over 7. You tip this and you times. So our equation would just simply become x is equal to, and we'll say 2,400 multiplied by 100 over 7. And that would give us the total salary of this employee. And this is 34,285.71 cents. And that is the employee's total salary. Question 2.5 says, the monthly salaries of the employees remains constant. So salaries remains constant. And the number of liters of fuel used each month, the fuel used remains constant as well, also remains constant. If the fuel price increases from 21 Rand 43 cents per liter to 22 Rand 79 cents at the beginning of the next month, how will the above ogive change? So looking at the ogive, what happens is the monthly salaries, that does not increase. Okay, and then their consumption also doesn't increase. They don't change how much fuel they use every month. That stays exactly the same. The only thing that increases is the price of fuel. So the study is still the 60 people. Nothing changes there. However, the percentage of their salary spent on fuel now, that's going to change because their salary did not change. That stayed exactly the same. But because the fuel price increased, they're going to spend more than they spent last month because that increased, but their salary stayed exactly the same. So what it will do is it will cause these percentages to increase as well. And when those percentages increase, because they're on the x-axis, it's going to cause a shift to the right, okay? They're going to increase like 5%. Somebody who spent 5%, for example, wouldn't spend 5. They'll spend more than that, okay? So all of these data points, they will just be shifted to the right. So it will cause the ogive itself to simply shift to the right. And that's what we can tell them. So this change will cause the ogive to shift to the right. And that is it for question 2. Question 3 says, in the diagram, A, which is 4 and 2, B, 6 and negative 4, and C, negative 2 and negative 3 are vertices of triangle ABC. T is the midpoint of CB. The equation of line AC is 5x minus 6y equals 8, and we should probably put that down. The angle of inclination of AB is alpha. Triangle DCT is drawn such that CD is parallel to BA. The lines AC and DT intersect at S, the y-intercept of AC, which we have the equation of. Then P, F, and R are the x-intercepts of DC, AC, and AB, respectively. And the first question asks us to calculate the gradient of AB. And we have 2 points, so let's go ahead and find the gradient. So the gradient of a line is found by saying the change in y over the change in x. Okay, and we can just follow one order. So we can go ahead and say top minus bottom or bottom minus top. I think bottom minus top is better here. So we can go ahead and say the gradient of AB is found by saying negative 4 minus 2 all over 6 minus 4. And that will be the gradient of AB. And that is going to be negative 6 over 2, which is negative 3. So negative 3 is our answer. Moving on to the next question. Calculate the size of alpha. So the size of alpha is over here, and it's the angle of inclination of this line AB, which we already have the gradient of. Okay, so remember that the gradient is negative, but we're trying to find the obtuse angle, as we can see. So this will be the positive we'll find. So we can find that by saying tan of theta, or in this case alpha, is equal to the gradient of AB, which is negative 3. And then we're going to use the second function of tan on both hand sides. You can see this as taking tan over. So alpha is equal to arctan of negative 3. Now immediately we try arctan negative 3. Look at what we get. Arc shift tan negative 3 on your calculator gives you negative 71.56 degrees. And that's because your gradient was negative. So it is not measuring anti-clockwise the way angles should be measured. Angles measure anti-clockwise. It's measuring clockwise. Okay, so it's measuring like that. So in order to get that angle, because it measured this way, all you have to do is add 180 degrees to get that value. Okay, you can kind of see it as you're on the straight line and you're adding 180 degrees. So once you reach here, you're at 0 and then it starts measuring. And then there we go. It's going to measure the obtuse angle. So we'll say plus 180 degrees, and therefore alpha is equal to, and round off to 2 decimal places, 108.43 degrees. And that is our answer. Question 3.1.3 says calculate the coordinates of T. And we know that T is the midpoint of this line BC. So let's go ahead and put the coordinates down, and then we'll find the midpoint. So we're finding T, the midpoints, and we're saying x1 plus x2 over 2. We can just say it's the midpoint of BC first. And then y1 plus y2 over 2. So this is going to be the coordinates of T, which will be, we'll say 6 plus negative 2, which just becomes a minus 2 over 2. And then negative 4 plus negative 3, which becomes a minus 3 over 2. And this finally just gives us, if we say 6 minus 2, we get 4. 4 divided by 2 is 2. And these two, they just give you negative 7 over 2. So just negative 7 over 2. And that is the answer. So those are our coordinates for T. Question 3.1.4 asks us to calculate the coordinates of S. And we know that S, as you can see, it's on the y-axis. So this is the y-intercept of this line, AC. When we are looking for y-intercept, you simply make x equal to 0. So let's take this equation and make x equal to 0. So in place of x, we say 0. And then this gives us 0. And this is negative 6y equals 8. And we can just divide both hand sides by negative 6 to solve for y. So y is finally equal to these both have a common factor of 2, so divided by 2 is 4, and divided by 2 is negative 3. So y equals negative 4 over 3. But as a coordinate, the x value is 0, and the y value is negative 4 over 3. And those are the coordinates of S. Question 3.2 says, determine the equation of CD. CD is a straight line, so to find the equation, we'll use y equals mx plus c, but we don't really have to use this formula. However, all we're looking for is the gradient and then the y-intercept, or at least one point on that line that can give us the y-intercept. Okay, so let's go ahead and look at CD. Looking at CD, right, this line over here, remember that we were told that CD and AB are parallel. So it means that they have the same gradient. So we need to find the gradient of AB, which we already have. It is negative 3. And we have a point on CD, negative 2 and negative 3. So we have our gradient and a point. So we can tell them that the gradient of CD is negative 3 and the point C is negative 2 and negative 3. So you can use y equals mx plus c, or you can use this formula. Y minus y1 is equal to our gradient, which is negative 3, times x minus x1. And then you're going to substitute in place of y1 and x1, you're going to substitute your available point. So this is going to be y minus negative 3, which becomes a plus 3, is equal to negative 3 times x minus a negative 2, which becomes a plus 2. So we can distribute on the right. That's going to be negative 3x minus 6. And then that 3 comes over and becomes a minus 3. So y equals negative 3x minus 9. And that is our answer. Question 3.3 says calculate, and 3.3.1, we need to find the size of angle DCA. So let's look at what this looks like in our diagram. So DCA is over here. So to find this angle, how do we do that? Okay, we can make some constructions here. So do you see that this angle is created by two important lines, two lines which we either have the gradient of or can find the gradient of. So to easily see this, you can draw an imaginary x-axis. Of course, this will be parallel to the actual x-axis. So this is just to understand that angle better. And now from this, we can see that this angle, okay, DCA, this angle over here, is created by finding the angle of inclination of this line DC, which we know is parallel to AB, so the gradient is negative 3. And then if you take that entire angle and you subtract it by this angle, the angle of inclination of line AC, which we have the equation of, we would find that angle. So that is our plan here. We can go ahead and say the angle of inclination of DC minus the angle of inclination of AC. So since we have the angle of inclination of DC already, let's just find that gradient of AC so that we can find its angle of inclination. So we would just need to ensure that this is in the form of y equals mx plus c, so we can clearly see the gradient, the coefficient of x. So 5x minus 6y equals 8, and we're going to make y the subject. So we can take negative 6 over, so that's negative 6 becoming positive, and then we have 5x minus 8 because that gets transposed. And then you can divide both hand sides by 6. Therefore, y is simply equal to 5 over 6x, and we can already see the gradient, and then that would simplify to negative 4 over 3. Okay, so our gradient, the gradient of that line AC, is actually 5 over 6. And now we can actually use this to find that angle DCA. So we'll find DCA by saying the angle of inclination of, like we said here, DC minus the angle of inclination of AC. Now we already have the angle of inclination of DC because that would also be alpha, since their gradients are exactly the same. Okay, and then we'll just find the angle of inclination of AC. So we knew that alpha was this 108.43, and we're going to use exactly that. Okay, so let's just write what we're doing here. Angle of inclination of DC minus the angle of inclination of AC. So this is that 108.43 degrees, and we're subtracting by the angle of inclination of AC. But here's how to find that. We would also just say tan of theta is equal to our gradient. And the gradient of AC, as we see, is 5 over 6. It's positive, so you do not have to account for any adding of 180 degrees, okay? Because it will form an acute angle. So we will say theta equals, and we'll say arctan of 5 over 6. Okay, so I'm not going to find that answer, and that's why I'm leaving it like this so that we can just use it here like that. So on our calculator, let's go ahead and find this. 108.43 degrees minus arctan of 5 over 6. And that gives us 68.62 degrees. And that is our answer. Question 3.3.2 says we need to calculate the area of POSC. Okay, so let's look at what POSC looks like. POSC is this shape over here, POSC. Okay, so that is not a trapezium, so we cannot use the area of a trapezium to find that. However, it's made of some shapes. And here, let's just point out two ways to find this. We can either decide to focus on finding the area of this triangle over here and then finding the area of this shape, because this shape is actually a trapezium. See how this is the x-axis? This is a line drawn parallel to the x-axis as well. And so that would be a trapezium. We have two parallel lines and we have a perpendicular height, since we know that the x-axis and the y-axis are perpendicular. Okay, so we could use that, or we could also do this. We could find the area of this larger triangle, and if you subtract it by the area of this smaller triangle, you will end up with the area of POSC, which I'm going to go for here. Okay, so to find the area of this shape, let's look for the things that we need to find first. We would need the coordinates of P, we will need F, and then you can decide to either use the area rule or to use a half base times height to find the areas of these triangles. So always try to go with the half base times height, and then if you cannot see a visible height, then go for the area rule. But with this one, we can actually form a height. You see, in this larger triangle, we can form a height by making this the base of the triangle, and then the height will be formed from this point. We'll see that as the highest point of the triangle down, and it's going to be perpendicular to the base. So the length of this line would depend on what this y value of c is. The y value of c is -3. Okay, so it means at this point, it's -2 and -3. So it means that the height of this triangle is 3 units. That's the height. It's 3 units. Okay, so we know the height and we just need to find the base. So let's go ahead and find F and P. So F lies on AC and it is the x-intercept. So we have the equation. We simply have to make y equal to 0 to find the x-intercept. So this is going to be 5x minus 6 times 0 is equal to 8. So that becomes 0 and we have 5x equals 8. Therefore, x equals 8 over 5. And so that would be F. F is the coordinates 8 over 5 and 0. Okay, let's go back up. So we know what this is now. It's 8 over 5. Then the next thing we need to find is P so that we can find the base of that triangle. So to find that, we can use this line DC, which we actually found the equation of. So DC will find P as the x-intercept on DC. Okay, so here's the equation of DC or CD. It is y equals -3x minus 9. And we'll simply make y equal to 0. So we're saying 0 is equal to -3x minus 9, transpose the -3x, so positive 3x equals -9, and if you divide both hand sides by 3, then x is equal to -3. Okay, so we know what P is. P is the coordinates -3 and 0. Okay, so that's -3. Now that we know that, that actually simplifies things here. And we already have F, you see. This actually makes everything very simple. So we're going to take the area of this larger triangle and subtract by the area of the smaller triangle. So this length, because it's on a horizontal line, you can simply find it by saying the highest x value minus the lowest x value. So that's 8 over 5 minus negative 3, which becomes a plus 3, which is 23 over 5, but we can also just call that 4.6 since it is just one decimal place. So we can call that 4.6, and we know the height is 3. Okay, so let's just put down these things. We know that PF is 4.6, and the height, the perpendicular height of this triangle is 3. Okay, so PF is 4.6, and the perpendicular height of triangle CFP is 3 units. Knowing that in this triangle, the smaller triangle, to find the area of that, we also need a base and a height. Luckily, we have the x and y axis here, so they are perpendicular, and that serves as the perpendicular height. So we just need to know what s is. S was negative 4 over 3. We already found it. Okay, negative 4 over 3. So we know the height of that. It's 4 over 3. This is negative 4 over 3. So we can also just tell them that OS is 4 over 3 units, and we also know the length of OF, the base of this little triangle, which would be 8 over 5 because you're going from 0 to 8 over 5. Okay, so we have everything down. And so how the area is going to work in a nutshell is like this. We will take, to find the area of POSC, we are going to take the area of the larger triangle, so the area of that triangle CFP, minus the area of the smaller triangle, this triangle SFO, and that's how we're going to find it. And then this is equal to, so we'll just find them separately. This is a half times whatever its base is times the height. The base is PF, which is 4.6, and the height is 3 units. So times 4.6 times 3, and then we'll subtract that by a half here times the base times the height. And as we can see, the base is 8 over 5 and the height is 4 over 3. So times 8 over 5 times 4 over 3. And that will give us our area. And that gives us 5.83 units. And that's recurring. 3 is recurring. So it's just going to round down to 3. And so we will say units squared. And that is the area of triangle POSC, and that is it for question 3. Question 4 says, in the diagram, M is the center of the circle, having PN as its diameter. KL is a tangent to the circle at N. Okay, and the first question is to calculate the coordinates of P. So do you see that P is one of the endpoints of the circle? And if this is the center, this is the midpoint. So we can use the midpoint formula to find this. Okay, so since we do not know what P is, we can call that X and Y. And we are finding the midpoint of this line, PN. So midpoint of PN. And this is found by using the midpoint formula, which is this. So remember that the midpoint we are focusing on is the midpoint of PN. Okay, so these are the endpoints. So that's going to be x1. And so we're saying this is x plus x2, which is 7 over 2, and y1 plus y2. So that's y plus negative 2, which is minus 2 over 2. But the thing is, we already know this midpoint. The midpoint itself is already here. It's 3 and negative 5. So it means that they represent the same thing. This is the calculation of the midpoint. This is the actual midpoint. So we will make their x values equal, saying that x plus 7 over 2 is actually equal to 3, and y minus 2 over 2 is actually equal to negative 5. Okay, so we can go ahead and cross multiply in this case, or multiply both hand sides by 2. And so we'll have x plus 7 is equal to 6. So x is equal to, we can transpose the 7, that's 6 minus 7, which is negative 1. And then here, same thing, we can cross multiply or multiply both hand sides by 2. So that's going to give us y minus 2 equals negative 10. And then y equals, transpose the negative 2, that is positive 2 minus 10, which is negative 8. And we finally found the coordinates of P. P is simply negative 1 and negative 8. And that is our answer. Question 4.2.1 says, determine the equation of the circle in the form of, so we need to leave it in that form. Okay, so to find the equation of a circle, we can first substitute the center of the circle, which is the A and B coordinate. So that's going to be x minus, that center was 3 and negative 5, so that's just A and B. Okay, so x minus 3 all squared, and then plus y minus negative 5, which is plus 5 all squared, equals r squared. So this equation is almost complete. The only thing missing right now is the r squared. So we'll substitute 1 point on the circle to find r squared. And you can take any point as long as it lies on the circumference. So we can take n, 7 and negative 2, and we'll simply say the x value is 7. So 7 minus 3 all squared plus negative 2 plus 5 all squared is equal to r squared. And then find out what that gives us. Okay, so 7 minus 3 is 4, so 4 squared is 16. And then 5 minus 2 is 3, 3 squared is 9. So that gives you 25. So 25 is equal to r squared. And now we can finally substitute r squared where it was missing. So therefore, the equation of our circle is x minus 3 all squared plus y plus 5 all squared is equal to 25, which is r squared. And that is our answer. Question 4.2.2 says, determine the equation, right, because it's KL, of KL in the form of y equals mx plus c. So to find KL, we can see that KL does not have any coordinates on it. So we're going to have to use something else to find its gradient, okay? But we know that the radius and the tangent are always perpendicular at the point of contact. So let's go ahead and find the gradient of the radius, and that will help us to find the gradient of the tangent. So these are our points, and the gradient is found by saying y2 minus y1. So that's negative 5 minus negative 2, which becomes a plus 2, over x2 minus x1, which is 3 minus 7. So that's going to give you 2 minus 5 is negative 3. 3 minus 7 is negative 4. So that gives you a positive 3 over 4. That's the gradient of mn, the radius. Now to find the gradient of the tangent, since we know that the radius and the tangent are perpendicular at the point of contact, we will find the gradient of line KL, the tangent, by simply switching the numerator and denominator and then multiplying that by negative 1. That way, it confirms that if you take the gradient of your radius and you multiply by the gradient of the tangent, it will give you negative 1. Okay, so we have the gradient of the tangent. And now that we have the gradient, to find the c, okay, y equals mx plus c, we found m. To find c, we just need 1 point on that line. We have a point. We have the point n, 7 and negative 2. So let's go ahead and substitute that. N is 7 and negative 2, which we have here. And we can use this equation y minus y1 is equal to the gradient, which is negative 4 over 3, times x minus x1. And so this will be our x1 and our y1. So we're simply saying y minus y1 is negative 2, so it's plus 2, is equal to negative 4 over 3 times x minus 7. And we just have to simplify. Let's start with the right-hand side. So distribute that and it becomes negative 4 over 3. X, distribute that, it becomes plus 4 times 7 is 28. And we have over 3. And then we can transpose the positive 2 and some minus 2. And we only have y left here. So y is finally equal to negative 4 over 3x. Okay, this can be expressed as 6 over 3. So that's 28 minus 6, which is 22. So that just gives us 22 over 3. Okay, so positive 22 over 3. And that is our answer. Question 4.3 says, for which values of k will y equals negative 4 over 3 plus k be a secant to the circle? So this refers to the previous line we got, the equation of KL. So for which values of k will it be a secant to the circle? If this is this line over here, okay, let's just mark it in blue. This is KL with the gradient negative 4 over 3. And we are manipulating the value of k, which was the y-intercept, okay? So currently at this point, it was a tangent, okay? So it intersected with the y-axis at positive 22 over 3. So over here, Yes, that's 22 over 3. And we need to ensure that it is a secant, not a tangent. So how do we shift it? We should shift it not up, because if you shift it up, that doesn't really solve your problem. Shifting it up, it just, you see, it's not even intersecting with the circle. So we need to shift it down. So if we move it down, you see that it's a secant all through. A secant would cut through a line at two places. Okay, so it's going to be a secant all through here. And as you're moving it down, and until it reaches a particular point again. So when it reaches this point over here, the end point of your diameter, P, it will become a tangent again. And after, if we move it any further than this, it will no longer be a tangent anymore. It just won't intersect with the circle. So we need it to stop here, okay? Don't go any further than that. So what should this be? Oh, we can consider what K was over here, okay? When this line is just extended, we saw that it passes 22 over 3. So it just needs to be less than whatever this is over here, and then nothing beyond whatever this y-intercept is, because we're controlling it from the y-intercept, since that line they gave us was y equals negative 4 over 3 plus k. So what should k be? Anything less than 22 over 3, but don't go anything further than whatever this y-intercept would be. So we can find that y-intercept because this is the same line, meaning it has the same gradient. So what exactly is the y-intercept of this line if the gradient is still negative 4 over 3, but this time it passes P? Okay, we have the coordinates of P, so we're going to go ahead and find that y-intercept if P is negative 1 and 8 and the gradient is negative 4 over 3. So we're really finding the equation of this line. It's kind of, but the focus is on C, to find C. So y equals, we can say mx plus c, in this case would actually be helpful, plus k really. And we will substitute that gradient, which is negative 4 over 3. And then in place of x and y, we can substitute our point. So this is negative 8 is equal to negative 4 over 3. And in place of x, we say negative 1 plus k. And this is going to become positive. But when we transpose it, it will become negative again. So that's going to be negative 4 over 3 minus 8 is equal to k. And let's find out what that is, which gives us, so k is equal to negative 28 over 3. Okay, so k is equal to negative 28 over 3. So we're really just saying that the y-intercept there would be negative 28 over 3. So where it intersects with the y-axis is negative 28 over 3. And what that value of k should be for it to be a secant, we're speaking about what the y-intercept should be. It can be values that are anything above negative 28 over 3, because if it's above negative 28 over 3, you see that it's just going to be like that, for example. Okay, so anything greater than negative 28 over 3, but nothing more than 22 over 3. So less than 22 over 3 can range between here, and it will be a secant. So that means that the value of k, the y-intercept, needs to be greater than negative 28 over 3, but less than 22 over 3. And that is our answer. Question 4.4 says points A, which is T and T, and B are not shown on the diagram. Okay, from point A, another tangent is drawn to touch the circle with center M at B from point A. Okay, so if we have our circle, this tangent is coming from a point A. So it's coming like that, could be in any direction. Let's say it did this. And it's going to touch the circle at this point B. And they told us that that A is T and T. So it's a tangent. We can use the relationship between the tangent and the radius of the circle. Okay, so with that being said, they say it's drawn to touch, and then we need to show that the length of the tangent of AB is given by this. So find the length of that tangent AB. Okay, how would we find the length of AB? Well, we don't really know what B is. However, there's some things we know, because we know that we had a radius, right? We had a center, M. And M was 3 and negative 5. Okay, so if that's M, then look at what we can actually do to find AB. We can connect these. Let's connect these two together. And we know the radius. We found the equation of the circle. And we can connect these two together. Now, because we know that the radius and the tangent are perpendicular at their point of contact, we can actually use Pythagoras here, which is clearly what they used because you see that they have a square root. Had they used the distance formula, then, B would still be in terms of x and y, unless you found a way to represent B. Okay, so here's the thing. AM can be found in terms of t, right, using the distance formula. So we'll say that to find AM, this is equal to the square root of x2 minus x1. So we can start with the t's. So that's t minus 3 all squared. And then plus, we'll say t minus negative 5, which is plus 5 all squared. So this is what we'll have for AM. Now, because we're going to use Pythagoras here to find AB, you might as well leave this as AM squared, since Pythagoras uses the squared sides of each of these lengths. So if we square both hand sides, AM squared would simply just be all of this without the square root because it would break open. So we would have the t minus 3 all squared, which we can distribute. That's going to be the first term squared, which is t squared. Last term squared, which is positive 9. First times second is negative 3t, and then you just times that by 2 to get negative 6t. Same thing over here. First term squared is positive t squared. Last term squared is 25. T times 5 is 5t, times 2 is 10t. Okay, so AM squared is simply equal to 2t squared, and then 10 minus 6 is positive 4t, and then 9 plus 25 is 34. So positive 34. That's what we have here. Okay, so that's AM squared. And now that we have AM squared, we can focus on finding BM squared, which is the radius, okay, from the center to the circumference, because this goes from A and it's a tangent to the circle at B. So what was the radius? I remember that being 25. Let's see. Okay, so yes. So the radius of the circle is 5, meaning r squared is 25. So we can use that just like that. And we'll say that the radius, let's not call it, you can call it BM, it's fine. BM, or the radius squared is 25. So that's BM squared. Okay, now let's go ahead and use Pythagoras to find AB. Okay, so to find AB, we'll say AB squared is equal to the longest side squared, which is AM squared, minus the other shortest side squared, which is your radius squared, or BM squared. Okay, and this would be AB squared is equal to, and we're saying AM squared, which is all of that, minus 25, so minus 25, which is BM squared, and we just have to simplify this. So this is AB squared is equal to 2t squared plus 4t still, and 34 minus 25 is 9. Okay, getting back to 9 again. And then if you square root both hand sides, AB is therefore the square root of 2t squared plus 4t plus 9. And that is our answer. Question 4.4.2 says determine the minimum length of AB. So this is an optimization question. If this is the length of AB, how do we find the minimum length? We would first have to find the value of t at which it is a minimum. So what we're seeing over here is under the radical, under the square root, we have a quadratic expression. Okay, to find the minimum of that, if you find the quadratic expression's minimum, that's going to be the square root of that quadratic expression's minimum as well. It will still be its smallest value. Okay, so let's go ahead and do that. Looking at that, if that forms a parabola, you see that to find that minimum, you're just finding the y value of the turning point. Now, there are two ways to do this. You can either use the x equals, or in this case, t equals negative b over 2a, or you can derive. Okay, I'll just derive because it will make this quicker. So we're taking the expression and we're finding the derivative of this. So let's find d over dt. Okay, so we're finding the derivative in respect to t. So this is what we have, and if you derive this, it's going to be coefficient times exponent for t minus 1, and then plus 4. And the t falls away, of course, because we have exponent minus 1, and anything to the power of 0 is 1, which just multiplies to the 4. Okay, and then once we do that, we're going to set this gradient, the derivative. When we derive, we're finding the gradient. We want to set the gradient equal to 0 because looking at that parabola, to find that turning point, the turning point happens where our gradient is equal to 0. So we find the gradient and then set it equal to 0. So 4t equals, and we transpose the 4, negative 4, divide both hand sides by t, which gives us negative 1. So we found the value at which this will be a minimum. This just means that that's the x value. It happens at negative 1. And now we actually have to find the y value because they specifically want the minimum length itself, not the value at which it will be a minimum. So to find that minimum length, we simply substitute this value of t into the equation of the length of AB. Okay, so this is going to be AB is equal to, and we'll substitute negative 1 in place of t. And the minimum length of AB is therefore equal to the square root of 7 units. And that is our answer. Okay, and that is it for question 4. Question 5.1 says, given the square root of 13, sine x plus 3 is equal to 0, where x is an element of 90 degrees to 270 degrees. Without using a calculator, we need to determine the value of sine 360 degrees plus x. So with the information they've given us, we can draw a diagram. So we have been given that the square root of 13 sine x plus 3 is equal to 0. And let's just isolate sine x so we can understand what sine is, whether it's positive or negative, and of course what the side would be. So that is sine x is equal to, if you took the 3 over first, it would become negative 3. And then we would divide both hand sides by that square root of 13 to get negative 3 over root 13. So sine is currently negative. And we have also been told that it goes from 90 degrees to 270 degrees. Now, we know that looking at the cos diagram, that sine is negative in the third and the fourth quadrant. But they tell us that it goes from 90 degrees to 270 degrees. So it's from 90 degrees to 270 degrees, meaning that's the second and the third quadrant. Now you see that the third would have the most ticks. So this diagram lies in the third quadrant. Okay, this is going to be a vertical line going to the x-axis, and it is perpendicular to the x-axis. And the angle x would be measured from here at 0 degrees all the way to that line. So that's x. Now we also know from SOHCAHTOA that sine is opposite over the hypotenuse side. So the opposite side is negative 3. So that's negative 3. And the hypotenuse is the square root of 13. So all we have to find is the adjacent side. Okay, so that's the adjacent side. You can say to find the adjacent side, a squared is equal to the hypotenuse squared minus the other shorter side squared. So minus negative 3 all squared. And then that's going to be a squared is equal to, and we have 13 minus 9. And a squared is equal to 4. And if we square root both hand sides, we have to consider the positive and negative solution. So it means that we have the adjacent side being equal to, looking at the diagram, do you see that this is on the negative part of the x-axis? So it is negative 2. So we have found that to be negative 2. And now we can solve for sine of this. Now, to be honest, we didn't even need that. That was just for the rest of the questions. But for this particular question, where they say sine 360 degrees plus x, all we have to do is this. Notice that we are adding an angle to 360 degrees. So it makes this angle greater than 360 degrees. When an angle is greater than 360 degrees, all you have to do is subtract 360 degrees from it so you can better understand that angle. So this would be minus 360 degrees, giving you sine x. And we know what sine x is. When we isolated sine x, it was equal to negative 3 over the square root of 13. and that is our answer. Question 5.1.2, we are asked to find the value of tan x. So tan from SOHCAHTOA, the TOA part, is opposite over adjacent. So the opposite side over the adjacent, so that's going to be -3 over -2. So we just have to tell them that tan x is simply equal to -3 over -2, which is equal to 3 over 2. And that is our answer. Question 5.1.3 says we need to find the value of cos 180 degrees plus x. So using the reduction, we know that 180 degrees plus x or plus theta, this lies in the third quadrant, and this is tan's quadrant. So cos is negative in this quadrant, meaning we have negative cos x, and cos in SOHCAHTOA is the ka part, so adjacent over hypotenuse. So the adjacent over the hypotenuse is -2 over the square root of 13. So this is negative, and then -2 over the square root of 13, which is finally equal to +2 over the square root of 13. And that is our answer. Question 5.2 says, determine the value of the following expression without using a calculator. So above, we have cofunctions being used. The cofunction identity for cos 90 degrees plus theta is negative sine theta. And then over and here in the denominator, notice that the 180 degrees is negative. So we're going to add 360 degrees to this. And so that's going to give you sine, and 360 plus -180 is 180 degrees, and we have plus theta. Then we have plus 3 sine, and here theta is negative, so we can add 360 degrees to this since the angle is negative. So we have 360 degrees minus theta is equal to, and this is negative sine theta all over, and this will simplify to, because this is in tan's quadrant, that is 180 degrees plus theta, so it becomes negative sine theta. Then we have plus 3, and it's being multiplied by sine 360 minus theta, which is in cos's quadrant. So sine is negative in this quadrant, so it becomes negative sine theta. So this is equal to, and we have negative sine theta all over, and that is just negative sine theta, and these two multiply and become -3 sine theta. Notice that in the denominator, these are like terms, okay? Negative sine theta and -3 sine theta. So they'll give you -4 sine theta. And then sine theta cancels. On the numerator, there's an invisible 1 in front of that sine theta that was there. So it's +1 over 4. And that is our answer. Question 5.3 says, determine the general solution of the following equation. Notice that they have already factorized it. So something times something gives you 0. It means that the first thing is either equal to 0 or the second is equal to 0. That is the only way we could multiply two things and they give us 0. So we're going to say cos x plus 2 sine x is equal to 0, or it is 3 sine 2x minus 1 that is equal to 0. And now we can just solve for these equations. So with the first equation, notice that we have cos and we have sine, and their angles are both x. So what we can do is create tan. So we'll leave 2 sine x here, and then we can transpose cos x. So it gives you negative cos x. And now we can form tan by dividing both hand sides by cos x. And the reason is because tan x is equal to sine x over cos x. Okay, so we're going to divide both hand sides by cos x. But let's just ensure that everything is fine after this. So when we divide sine by cos, we're going to get tan x, but then there's still a 2 here. We just want tan x to be on its own and all the numbers to be here. So we are going to divide by 2 cos x. And that way the 2 cancels here and you're left with tan x. And this is equal to -1 over 2. Because the 1 is in the numerator still. So this is what we have here, and we need to solve for tan x being equal to -1 over 2. Now to solve for tan x being equal to -1/2, we can use the diagram method where you look for where tan is negative, but with the tan graph, this is unnecessary. It doesn't behave like the sine and the cos graph, where, for example, with the sine of x graph, where the y value is equal to a half, for example, you see that within the period of 0 to 360 degrees, there will be two solutions for that. The tan graph doesn't really work like that. With the tan graph looks like that, then we have an asymptote, and then like that. You see that within 0 to 180 degrees, so let's say we're looking for negative a half, right? It's only going to appear in one place, and then it's going to appear 180 degrees later and 180 degrees later and even 180 degrees before this. Okay, so because of that, don't really need to use the table method. This is what we can do. We can find the reference angle first, and you find the reference angle by saying arctan negative a half. So I'm not going to consider the absolute value of this. So arctan negative 1 over 2, and that gives me this, and that's not a problem. We're going to take it as it is, negative 26.50. We can round off, it's fine, 57 degrees. Now, because this angle is negative, we can still make it positive at the end. But here's how we'll solve for x here. So x, right, what we're solving for is equal to, and we have negative 26.57 degrees. It is only negative because of where it is on the diagram, okay? But you can make it positive, simply remembering that the tan graph repeats itself every 180 degrees. So if you add 180 degrees to this, you will get that general answer that you would get if you use the table method, the Cartesian plane method. So this is plus 180 degrees, and then you see that you would actually get 153.43 degrees, and we can say that it's this plus k of 180 degrees because the tan graph repeats itself every 180 degrees. Okay, so that is going to be our answer for the tan graph, and you do not have to include the other one just because of the way the tan graph behaves. Okay, and then we can also just make sure to note that k is specifically an element of integer values. Okay, and then we have 3 sine 2x minus 1. So we can isolate sine 2x by saying this is sine 2x is equal to, and we transpose the negative 1 to get positive, and then divide both hand sides by 3. So that is 1 over 3. Okay, so this is what we have, and we can find our reference angle at this point. So the reference angle is equal to arc sine of 1 over 3. Now that is shift sine of 1 over 3. Now we're not going to round off to 2 decimal places yet because we still have 2x over here. So we're still going to have to divide. So this is going to be 19.47, 1, and that keeps going. And now when we're solving for x, this is what we're going to do. So we're going to say 2x is equal to, okay, it's always this value here. And this is equal to, it is 19.471. Now you can already see that sine is positive. So this is going to be the first and the second quadrant's reduction. So the first one is just theta. The second is 180 degrees minus theta. So this is the 19.47. Then we'll say plus k of 360 degrees because the sine graph repeats every 360 degrees. And that is the first solution. And then we'll say, or 2x is equal to, and to find the second one, we'll say 180 degrees minus the 19.47. Okay, so we'll hold on to that. So here, let's go ahead and solve for x. So you can divide both hand sides by 2 to solve for x. And so x is equal to, and we're going to take this and just divide it by 2. So that gives us 9.74 degrees. Okay, it rounds up. And then we have plus k of 180 degrees since it divides by 2. And here we're going to just find out what 180 degrees minus that is. So it's 180 degrees minus shift sine 1 over 3, which is going to be, and then we'll still say plus k of 360 degrees, of course, where k is an element of integers. And then we can divide both hand sides by 2. And this is x is equal to, and if you take all of that and you say divided by 2, you get 80.26 degrees plus k of 180 degrees. Let me just leave that k is an element of integers at the last answer, okay? So x is either equal to this or this, or x is equal to that. Okay, so that is our answer, and those are our solutions. Question 5.4 says, given the identity cos of x plus y times cos x minus y is equal to this, we need to prove the identity. Okay, so you see that we need to prove that the left-hand side is equal to the right-hand side. So let's rewrite this left-hand side. So if we expand this using compound angles, this is going to be cos x cos y, and because it's a plus, it changes to minus sin x sin y, but it's being multiplied by this. So that would change to cos x cos y, and that changes to plus sin x sin y. So they're being multiplied, and we can expand it. So expanding this, you would notice it's actually a difference of two squares, because this is exactly the same as this, and so are these two. But then we have a minus and then a plus. So since it's difference of two squares, you're just going to square that. You're really just multiplying these two together. So it's going to be cos squared x, cos squared y, and then these two together. So it's minus sine squared x, sine squared y. Okay, now at this point, we need to focus on what the right-hand side looks like and see how we can get from this to the right-hand side. Okay, so I'm just going to go with this. Do you see that we don't have any cos? It's only sine x sine y here. So, and there's also a 1 here. So let's just see. Let's try changing the cos squared x using the identities. So we can change cos squared x to 1 minus sine squared x, because sine squared x plus cos squared x gives us 1. Okay, that's probably where that 1 is coming from. And then we can change cos squared y to 1 minus sine squared y, and then we still have minus sine squared x sine squared y. Okay, so at this point, the only thing we can do here is to distribute that. They're not the same, so it's not difference of two squares. Okay, that last term is not the same. So you would have to expand it using FOIL. So we're going to multiply first times first, 1, first times second, that is negative sine squared y. And then second times the first here is negative sine squared x. Okay, this is already looking like it. And then these two multiply and become positive sine squared x sine squared y. And that subtracts with this negative sine squared x sine squared y. So these two subtract because they're exactly the same, just the positive and negative. And so our answer is 1 minus sine squared y minus sine squared x. And that is indeed the right-hand side. So that proves that the left-hand side is equal to the right-hand side. Question 5.4.2 says, hence determine the value of 1 minus sine squared 45 degrees minus sine squared 15 degrees. Notice it's in the same order as the previous question. So we saw that this right-hand side and the left-hand side are equal. Okay, so it means that we can change this to this because there's not much we can do with this right now. Okay, so what we're going to do is change it. So we'll say it's equal to, and we'll make it equal to this since the left and the right-hand side were equal. But in place of x, we're going to place what our x was here. So this would be y and then that would be x. You can actually just leave it in that order. That's fine. So this would be, I know mine is in the form of y and x, but theirs was first x and then y. So it's fine. We can make this our x and that is our y. So in place of x, say 45 degrees, and in place of y, say 15 degrees. So plus 15 degrees here, and here minus 15 degrees. Okay, so this is now going to be equal to, that's simply just cos of 60 degrees added together, multiplied by cos 30 degrees. And then this is equal to, using special angles, you can find that. Now, if you use the calculator in this one, it actually will not show because it's the angle 60 and 30. So it's fine. But cos 60 is the same as sine 30. And sine 30 degrees is equal to a half. And cos 30 is the same thing as sine 60 degrees. And sine 60 is equal to root 3 over 2. So this is equal to numerator times numerator and denominators multiply. So square root of 3 over 4. And that is our answer. Question 5.5 says, consider the trigonometric expression, and this is what we have. And they want us to rewrite the expression as a single trigonometric ratio. So this is equal to, do you notice that we have two terms? And in each term, we have common factors. So between 16 and 8, the common factor is 8. And then we have sine x in common and also cos x is common. So we can take out that common factor. And so that is going to be 8 sine x and cos x. And so what we're left with in the first term, you can simply say this divided by this common factor. So this will be 2, and we have cos squared x. And then on this side, what is left? Notice they're exactly the same, so it's simply minus 1. Okay, so a single trig ratio. This is going to be equal to, notice that this looks a lot like 2 sine x cos x. And that's because we can actually make it that by taking out a common factor of 4. So this is 4 times 2 sine x cos x. And this is really the double angle expansion or identity for cos 2x. This is one of the things that it's equal to. This is in your formula sheet as well. So this is going to be 4 multiplied by, and that is the double angle identity for sine 2x. So you've got 4 sine 2x times cos 2x. And together they look a lot like 2 sine A cos A, if A was the 2x. And of course, if we remove the common factor of 2 from there, so that's what we can do. Take 2 out as a common factor and rewrite this as 2 times 2 sine 2x cos 2x. And then this is going to be 2 times. And now this, because this simplifies to sine 2a, it would also simplify to sine 2 multiplied by the angle that you have here. That is our a that we were referring to. So times 2x. So this is simply just 2 sine 4x. And that is the single trig ratio that it simplifies to. Question 5.5.2 says, for which values of x in the interval where x is an element of 0 degrees to 90 degrees will this function have its minimum value? Okay, so it currently looks like this, 2 sine 4x. Let's just look at what the original sine graph would have looked like and where that minimum would be. So the original sine graph, sine x, right, would have simply just gone like this, hit 1, and then hit -1, and then back at 0. Okay, but this is 2 sine 4x. So when you put a 2 here, it's going to reach a height or highest of 2 and a lowest of -2. Okay, so now its highest is 2 and the lowest is -2. But now lastly, remember this is 2 sine 4x. Okay, so naturally the 2 sine of x graph would have ended here at 360 degrees, meaning it finishes one cycle in 360 degrees. But when we put 4x, what it's going to do is it's going to finish a cycle 4 times faster. And how you find out how many that will be is by taking the old period and dividing it by that number, the coefficient of x, which is 4. And so that would be 90 degrees. And that's probably why they're telling you to find it within 0 to 90 degrees. Because this graph is not going to look like this anymore. It will be squeezed and it will complete one cycle within 0 to 90 degrees. So still thinking about this, when it went from 0 to 360 degrees, where was the minimum value? The minimum would be at -2, right? That's like that -1. So we go 0 degrees and 0, and then 90 degrees and 2, and then 180 degrees and 0. And then this would have been 270 degrees and -2. That's what it would have been. But you see how the period changed, where the period was 360 degrees, but then it just got divided by 4. Well, that's what all the other angles are going to do. All the x values will also be divided by 4. So this used to be at 270 degrees. Now it's going to be over here, and you will find that by saying, we'll say 270 degrees divided by 4. That is not negative. Okay, and let's find out what that gives us. Okay, so that x value is 270 degrees divided by 4, which is 67.5 degrees. Okay, so that is our minimum. For which values of x in the interval will this have its minimum value? It will happen at x equals 67.5 degrees. And that is our answer. Question 6 says, in the diagram below, the graphs of f of x is equal to tan x, as we can see over there, the tan graph, and g of x is equal to 2 sine 2x are drawn for the interval where x is an element of negative 180 degrees to 180 degrees. A, which is 60 degrees, and K, and B are 2 points of intersection of F and G. Question 6.1 asks us to write down the period of G. Okay, so the period of a graph is how long that graph takes to complete a single cycle. So the graph of G is a sine graph, and it is 2 sine 2x. A natural sine graph takes 360 degrees to complete a cycle, but this sine graph has been altered, okay? The period has been altered. We can see that because we have a coefficient in front of the x. So how we find out what the new period is by taking the old period divided by the coefficient of x, which is 2. So it's 360 divided by 2, which is equal to 180 degrees. So this sine graph, which was supposed to complete a cycle within 360 degrees, it completes one single cycle, as we can see, within 180 degrees. And that is our answer. Question 6.2.1 says, calculate the value of K. Okay, so K is over here. And you can see that it lies on this point, okay? It's on the graph of F and G as well. So you can use either graph to find it. Notice that you've been given an X and a Y value. And so we just have to substitute that into either G or F. Okay, it's easier to use F because it's a simple looking graph. We'll say f of x is equal to tan x, and in place of f of x, the y value, we'll say k, and then it's equal to tan of the x value was 60 degrees. So just find out what exactly tan 60 degrees is, and that is our answer. And tan 60 is equal to the square root of 3, and that is our answer. Question 6.2.2 says, calculate the coordinates of B. Okay, so let's look at what B looks like. B is over here. Now, there's something interesting going on here. Just look at within one cycle of the graph of G and the graph of F. Okay, remember that the graph of F is the tan graph. So this is one single cycle because the tan graph completes a cycle in 180 degrees. But this is also one single cycle in the sine graph because the period has been altered and now it's completing a cycle in 180 degrees as well. So do you notice that the graph of G and the graph of F, they intersect here at 60 degrees and the square root of 3, which we just found. Now, this answer will repeat itself 180 degrees after this, okay, ahead of this, and 180 degrees behind this. So where we see that happening again is over here. See, you have a graph of G, the sine graph, and then the tan graph, and they intersect again. So that's how we would find that this was at 60 degrees. This same answer will repeat itself again 180 degrees behind. So to find this, the y value is exactly the same. It's still the square root of 3, but the x value will be 60 degrees minus 180 degrees. Okay, and the same answer, you see the sine and the tan graph, they will intersect again 180 degrees after this. Okay, so that is how we find that. They want the coordinates of B. The x coordinate of B is found by saying 60 degrees minus 180 degrees, and x is equal to negative 120 degrees. And we know the y value is still the square root of 3. So B is simply negative 120 degrees and the square root of 3. And that is our answer. Question 6.3 says, write down the range of 2g of x. So what have they done to g of x? They have applied a 2 in front of it. So we need to multiply g of x by 2. So g of x is currently 2 sine 2x. And then we're just going to multiply a 2 to it. So 2 sine 2x. And now 2g of x would be 2 times 2 sine 2x, which is 4 sine 2x. So what would be the range of this? Well, there's a 4 there, and you can see that this is not being shifted up or down. So your sine graph would look like this. It goes up and then down. But the highest it would reach now, because this is a 4, is it will reach a highest of 4 and a lowest of negative 4. So do you see the range? The range refers to all the possible y values of this graph. So this graph is going to go from negative 4 to 4 and nothing beyond that. So we can go ahead and tell them that our range is y is an element of, and it goes from negative 4 all the way to 4. And that is our answer. Question 6.4 says, for which values of x will g of x plus 5 degrees minus f of x plus 5 degrees be less than or equal to 0 in the interval where x is an element of negative 90 degrees to 0 degrees. So let's look at where this is on our graph. We're going from negative 90 to 0, so we are only allowed to look within this interval. So don't look at any other part, just here. Okay, so we need to find out where this minus that graph gives you a value less than or equal to 0. Here's what you can do when you see this situation, when you see that they're being subtracted. You can simply transpose this one, okay, the negative one. So this is actually g of x plus 5 degrees, and then it is less than or equal to f of x plus 5 degrees. So this is what we're looking for. We're looking for where g, okay, of course, plus 5 degrees, is less than or equal to f of x plus 5 degrees. So what we can actually focus on first is where they are equal, where they intersect. And this would be one of the places we'll be able to mark and compare those two graphs and see where does g lie below f. Okay, where does it have lower y values than the graph of f? Okay, so let's go ahead and see that. Where do they intersect first? They intersect over here. Okay, now for us to even be able to answer them, we would need to find out exactly what that point of intersection is. And then, of course, we will apply that 5 degrees shift. So where do they intersect? You can use the symmetry of the graphs to do this. You see the sine graph. Okay, so do you see what it's doing over here? Like that, the way it goes up and then down like that. It's going to do the exact same thing over here. It's just upside down. Okay, so it looks like this. So you can see it like this. If it took 60 degrees from 0 to 60, okay, to intersect with the graph of f over here, it's going to do the exact same thing on this side. It's going to take 60 degrees as well to intersect with the graph of f, because the graph of f is also symmetrical. What it does over here, it does the same thing over here as well. So they would also intersect 60 degrees later, okay, but this time 60 degrees to the left. So this happens at negative 60 degrees. Okay, we're just using the symmetry of the graphs, and that's how we find out that. Now we need to specifically focus on where g of x, or, we're still going to apply the 5 degrees, but where g of x plus 5 degrees is less than or equal to f of x plus 5 degrees. So where is g less than f within this interval? Notice that the graph of g, it lies below the graph of f from negative 60 degrees all the way to 0 degrees. Okay, that is where that happens. But now apply this 5 degree shift. This says plus 5 degrees. When we apply a shift to the x value, you're either moving to the left or to the right. When it is a plus, it's moving to the left. Okay, when it is a minus, it is moving to the right. So this is a 5 degree shift to the left. So all you have to do is, you see where your answers would have been. We can see that it is less than or equal to f of x between where x is greater than or equal to negative 60 degrees, okay, because at that point, you see they do intersect, they are equal there, which is one of the requirements, but less than 0 degrees. Okay, and then 0 degrees, do you notice that it's also equal at this point because they both intersect at the origin as well. So it's less than or equal to 0 degrees. That's one of the requirements. And then we can apply that shift. So we know that it's moving 5 degrees to the left. So from negative 60, 5 degrees to the left is negative 65 degrees. And 5 degrees to the left here would be at negative 5 degrees. So we'll just apply that there. So the answer here is that x is greater than or equal to negative 65 degrees, but less than or equal to negative 5 degrees. You can also put this in intervals. So that would be x is an element of, and it goes from negative 65 degrees as an included value, and then all the way to negative 5 degrees also as an included value. And that would be our answer. Question 6.5 says, determine the values of p for which, and they say sine x cos x is equal to p, will have exactly 2 real roots in the interval where x is an element of negative 180 degrees to 180 degrees. So we're looking at this sine x cos x, and that probably looks very familiar because there is a double angle identity for this. If we look at sine 2x, this is equal to 2 sine x cos x. And you can make sine x cos x the subject by simply dividing both hand sides by 2. If you divide by 2 here, what you end up with is there is a coefficient of 1. So this is actually a half sine 2x that is equal to sine x cos x. Okay, so we found out that that is actually a half sine 2x. And that is what is equal to p. We need to find out how it will have exactly 2 real roots. What should p be for this to happen? So p is going to either shift that graph up or down. You can decide to take it over. It's not really necessary. We can even watch it from this side. Okay, so what should p be? We can actually look at that over here. We don't really have to look at our graph, but to avoid drawing new graphs, let's look at it here. Now that graph, a half sine 2x, okay, it looks a lot like this graph. The only difference is this one says 2 sine 2x. So this one, the highest would be 2 and the lowest would be negative 2. With a half sine 2x, the highest would be a half and the lowest would be negative a half. Now you'll notice that we can actually use this graph and pretend that it goes to the highest of a half and the lowest of negative a half because it will not affect our answer. We're just shifting it up or down. So if we drew out this graph so that we can understand how to shift it, this is what happens. Currently, this graph has how many roots, how many x-intercepts? It has an x-intercept here, 1, 2, 3, 4, and 5. We needed to have 2 roots. So we can decide to either shift this graph up, and if you shift it up so that the turning points sit on the x-axis, you see that it would have exactly 2 roots. Okay, this does not extend down, it cuts off at this point. So we're going to shift it up exactly by, since this is negative a half, you shift it up by exactly a half unit so that it can sit on the x-axis. So that's the first shift. It can either be a half moving up or it could be a half moving down. Okay, if you move it from this point and you move it to the x-axis, do you see now that it will have exactly 2 roots? So that explains what p should be. P can either be, because it is just a shift, regardless of whether you take it over or not, it can simply either be positive a half, and if you make it positive a half, this would shift it down because you say a half sine 2x minus p, and so if you apply that there, that's just going to be minus a half. So that would shift it down to make it have 2 roots, or p could also be equal to negative a half, and of course that would shift that up for the same reason, and that would be our answer. And that is it for question 6. Question 7 says AB is a vertical flagpole that is the square root of 5 meters long. And then AC and AD are 2 cables anchoring the flagpole. B, C, and D are in the same horizontal plane. And then we are also given that BD is 2p meters, and ACX, this angle over here, that is x, and ADC, this angle over here, is 45 degrees. So the first question, 7.1, says, determine the length of AD in terms of P. So AD is over here. And we need to ensure that we relate it with some shape, okay, triangles clearly here, that includes AD. So that would be this right angle triangle over here. Normally with these questions, we would use trig ratios to solve for this. But please notice that this 45 degrees is not the angle measured here inside this triangle ABD. That's not that angle, okay? That is the angle measured for the outer triangle that we are seeing here, this bigger triangle. So what we can use to find AD would be, because we have been given this side, and this is a right angle triangle, we can simply use Pythagoras. So let's go ahead and do that. We would say that AD squared is equal to, and that is the hypotenuse, so the two shortest side and individually squared. So that is square root of 5 and then p all squared plus 2p all squared, and then this is equal to, we'll say AD squared is equal to, and when you square the root 5, it becomes 5, and we have p squared. When you square 2, it becomes 4, and p squared. So that would give us 9p squared. So AD equals 9p squared. Then to solve for AD, we can square root both hand sides. We don't have to consider the positive and negative solution because these are lengths, so they will always be positive. So this is 3p, and there we go. That is AD in terms of p. Question 7.2 says, show that the length of CD is equal to this. Okay, so we just need to find CD. So CD is over here, and looking at CD and the triangle that we're going to use to find CD, we need to use a triangle that would have dimensions available, like angles and sides. So using this one on the bottom is not a good idea right now because we don't even have any angles there. The only side we have is BC, and then that's about it. So let's focus on using this bigger triangle over here. So in this triangle, what can we use? Well, we've got two opposite dimensions, C, an angle over here, and a side that are complete. So since we're looking for CD, we could focus on finding this angle CAD first, since it is opposite CD. And then we could use the sine rule here. So how do we find this angle A, that CAD? We can find that because we have two angles in this larger triangle. Remember that the angles in a triangle add up to 180 degrees. So that angle CAD would be found by saying 180 degrees minus x minus 45 degrees. So angle CAD equals, we'll say 180 minus x minus 45 degrees. And this gives us, that's going to be 135 degrees minus x. Okay, so now that we have that angle, we can use the sine rule. So using the sine rule, because we are looking for a side, we can just start by saying CD over sine of the angle opposite, which is 135 degrees minus x. And then we'll say this is equal to AD over sine of the angle opposite AD, which is x. Okay, so that's what it's going to look like. But just remember, we already know the length of AD is 3p, so we can just say 3p. Okay, so this is what it looks like. So the only thing we need to simplify would be that sine 135 degrees minus x. So we have CD over, and let us just, you see that's 135 degrees. We can actually pull out a 90 degrees from that and then use cofunctions. So this is sine, and we can split that 135 degrees as 90 degrees plus 45 degrees. That's what gives you 135 minus x. And really what we're doing here is we're trying to group these two together as if they're one single angle and then apply cofunctions. Then this is equal to, we have 3p over sine x. And now let's just continue simplifying that. So we have CD over And that becomes, you see, if you have sine 90 degrees plus an angle, it is equal to, the identity would be cos of that same angle. So this would become cos of 45 degrees minus x. Okay, and then at this point, we can focus on getting CD on its own. So we still have sine x here. And to get CD on its own, you can transpose cos 45 degrees minus x. In other words, multiply both hand sides by cos 45 degrees minus x. So this is CD is equal to, and we'll have 3p, and that got multiplied. So it moves here to the numerator, and it is cos 45 degrees minus x all over sine x. And we just have to simplify that because you see, that's not what it looks like over there. So let's go ahead and simplify. CD is equal to 3p, and we can use the compound angle identity for cos 45 degrees minus x, which is really cos A minus B. So that's going to become, they'll become two terms, so we'll put them in brackets. So it's going to become cos 45 degrees times cos x. Then because we have a minus, it changes to a plus. Sine 45 degrees sine x. And this goes all over sine x. Okay, so still simplifying that part. CD is equal to, we still have 3p multiplied by this cos 45 degrees. It is best to not use the calculator, because if you use the calculator, your answer will not look like theirs. And then you may end up panicking, thinking you've done something wrong. So you can either use the triangles for your special angles or the circle, that 2-unit circle that we use. But in this question, I'm going to use a rule called the OHA rule. So we start by saying OHA. So this is used for special angles. And then the angles we'll put down is 30 degrees, 60 degrees, and 45 degrees. Then we'll say 1, 2, 3, 3, 2, 1, and 1, 2, 1. Okay. And then in each row with the numbers, we're going to square root the biggest number. So here the biggest number will be 3. We square root. Here biggest number is 3. And then the largest number is 2. And this is how we're going to solve for these functions with special angles. Cos 45 degrees, right? Remember that from SOHCAHTOA, cos is adjacent over hypotenuse. So we'll go to the 45 degree row and we'll take the adjacent side, which is 1, over the hypotenuse, which is the square root of 2. So that becomes 1 over square root 2 multiplied by cos x. And you see that if you multiply these two together, because this is in the numerator, it really just becomes cos x over root 2. Then we'll say plus, and then sine 45 degrees. Sine is saw, opposite over hypotenuse. So go to the 45 degree row, and we say the opposite is 1 over the hypotenuse of square root 2. Same situation. 1 over root 2 is multiplying by sine x. So that just gives you sine x over root 2. And we can see their denominators are the same. So this still goes over sine x. At this point, you can even apply the sine x over here. So I'm going to take the 3p and divide by the sine x. So 3p over sine x. And you see there's a bracket in front of this. You see these two can just go together and you're still multiplying by all of this. So we're multiplying by these two because their denominators are the same. They can be written under the same denominator. So that is cos x plus sine x. Let's put it in their order. They said sine x plus cos x. So we can already start from there. And this goes all over the square root of 2. And so therefore, CD is equal to, and we're multiplying 3p with something that has 2 terms in the numerator. So make sure to put brackets. So that's going to be times sine x plus cos x all over, and sine x times root 2 is root 2 sine x. And that is our answer, just as they have it as well. Okay, and that is it for 7.2. Question 7.3 says, if it is further given that p is equal to 10 and x is equal to 110 degrees, calculate the area of triangle ADC. So let's look at that triangle. the area of triangle ADC. So this is this highlighted triangle over here. And they've given us the value of P and X. So we can clearly use the area rule in this case, because you can see that we don't really have a perpendicular height. That height has nothing to do with that triangle. It's not that triangle's height. So here is how we can use the area rule here. Let's take a simple looking angle. We already have this, and the sides we have AD and we have CD. So we can take those two sides and this angle. Remember the area of a triangle using the area rule. If you have a triangle ABC, you can say a half multiplied by AB multiplied by AC, and then sine of the angle in between those sides. So sine of angle A. And that's what we're going to use here. So this would be a half multiplied by AD multiplied by CD, and then sine of that center angle, which is 45 degrees. And then we'll just substitute AD and CD and then substitute the value of P and X. So this is equal to a half multiplied by AD is 3P. We already found that initially in the triangle 3P, and then AC as well. So this is just 3P, but we know what P is now. P is 10, so P times 10. And then CD is over here. So we'll just take this, and in place of P and X, just substitute the P and X values. So this looks like this. And in place of P, we'll just say that is 10. In place of X, we'll say that's 110, and that's 110. And then over sine of square root 2 sine of 110 degrees. So this just has to do with substituting. Then lastly, multiply by sine 45 degrees. So times sine 45 degrees. And let's put that on our calculator and find out the area. And there we go. This is our answer. This is finally equal to 143 points, and that rounds up to 11. And these were in meters, right? They actually said they were in meters. So that would be meters squared. And that is our answer. And that is it for question 7. Question 8, 8.1 says, in the diagram, O is the center of the circle. MNPR is a cyclic quadrilateral, and SN is a diameter of the circle. Then we have chord MS and radius OR are drawn, and we are told that angle M2 is equal to 64 degrees. The first question is to determine, given reasons, the size of the following angles. And the first angle we need to find is angle P. Now notice where angle P is. Angle P is at the circumference. And we know that this shape is a cyclic quad. Now we have the angle opposite angle P. What do we know about the opposite angles in a cyclic quad? They are supplementary, meaning they add up to 180 degrees. So angle P will be found by saying 180 degrees minus 64 degrees. And of course, we will put down our reason. And this is equal to 116 degrees. And that is our answer. Question 8.1.2 says we need to find the size of angle M1. So once we find an angle, it's best to put it down because it will probably help you with the next question. So this is 116 degrees. And now we need to find angle M1. So M1 is over here. It is at the circumference, and we could have been able to use O1, but O1 is not present. So we would need to use something else. It's at the circumference, but you notice that we have SN, which is a diameter, and this is part of the angle supported by the diameter at the circumference. So it means that these two, they should add up to 90 degrees because the angle in a semicircle is equal to 90 degrees. So we can simply tell them that angle M1 would be found by saying 90 degrees minus 64 degrees, and we'll give them the reason. And angle M1 is therefore equal to 26 degrees. And that is our answer. And we'll also fill it in the diagram. Question 8.1.3, we need to find the size of angle O1. Okay, so that has been filled down. And O1 is what we spoke about previously. So you see how this arc SR is supporting angle O1 at the center, but it's also at the same time supporting angle M1 at the circumference. So the angle at the center is twice the size of the angle at the circumference as long as they are supported by the same chord or arc. So angle O1 is double of 26 degrees. So we can tell them that angle O1 will simply be found by saying 2 times 26 degrees. And of course, we'll give them our reason. Okay, there we go. And so therefore, angle O1 is simply equal to 52 degrees. And that is our answer. Question 8.2 says, in the diagram, ABG is drawn. Then D and E are midpoints of AB and AG respectively. AG and BG are produced to C and H respectively, and then F is a point on BG such that FG is parallel to CH. Okay, so we've got these here, and the first question is we need to give reasons why DE is parallel to BH. Why are these two lines parallel? Well, looking at this diagram with this triangle over here, you can see that D is the midpoint of AB and E is the midpoint of AG. This is the midpoint theorem that we can use here. Okay, not the converse, the midpoint theorem. The midpoint theorem says that if AD is equal to DB and AE is equal to EG, then what we can conclude is that DE is first of all parallel to BG and that BG is equal to twice the size of DE. So the main reason they are parallel is because of the midpoint theorem. And that is our answer. Question 8.2.2 says, if it is further given that FC over BF is equal to 1 over 4, it's best to start putting that down. So FC over BF. FC takes 1 part, so we can call that A. BF takes 4 parts, so we can call that 4A. Okay, so that's what we have there. And then they say DE equals 3x minus 1. DE is 3x minus 1 and GH is x plus 1. So GH, this part, is x plus 1. And they want us to calculate, given reasons, x. Okay, so looking at this, to find x, we need an equation to be able to find x. And the best way to form an equation right now would be in this, because we actually know the ratios of this side. So for us to do that, because these lines are already parallel, we can find BG first. But here's the thing about BG. We know that BG is going to be twice the size of this. So we can actually tell them that. So let's find BG first. It will be in terms of x. But BG is twice the size of DE, which is equal to 3x minus 1. And it is twice the size because of the midpoint theorem. I think I said formula. It's supposed to be theorem. So BG in terms of x is equal to 2 times 3x minus 1. And so therefore BG is simply 6x minus 2. Okay, so now we have a value for BG. This is simply 6x minus 2. And here's where our equation comes. Because these lines are parallel, we can use the proportionality theorem on this. So we can go ahead and tell them BG over GH is equal to, and then we tell them what it's equal to. You can use it in this form as well. It's also fine. So yeah, let's just go like that. So we're looking at FC over BF. So we will take GH over BG. So it corresponds with FC over BF. So that would be equal to, because of the proportionality theorem, FC over BF. FC over BF. And we can either give the reason proportionality theorem or tell them it's because we have a line drawn parallel to one side of the triangle. But you would probably notice it's easier to just say prop theorem. So there we go. Okay, and now we can just fill in what they are. So GH is, like they told us, x plus 1. So in place of GH, we say x plus 1 over BG, we found to be 6x minus 2, is equal to FC over BH f is simply just 1 over 4. So this is equal to 1 over 4. And now we can solve for x. So we can cross multiply straight away. So that is just going to be, let's multiply those two together first. So that's going to be 6x minus 2 is equal to, and if you say this times 4, remember this is one term, it must multiply with both terms. So times x is 4x times 1 is positive 4. Then transpose everything with x. So that's going to be 6x minus 4x, which is 2x, is equal to, and that is 4 plus 2, which is 6. And if you divide both hand sides by 2, x is therefore equal to 3. And that is our answer. Question 9.1 says, in the diagram, O is the center of the circle, and then we have OD bisects the chord AB. Now we have to prove the theorem, which states that the line from the center of the circle that bisects a chord is perpendicular to the chord. So that is that OD is perpendicular to AB. Okay, so this is really just the converse of that first theorem that you learn. To prove that these two are perpendicular, it's going to be very similar to the way we prove that the line from the center of the circle perpendicular to the chord bisects the chord. So we're going to start with constructions. We're going to construct a line from O to A and then a line from O to B. And then we need to write down any constructions made. Okay, and then after we have done that, we can focus on this. We can prove that these two triangles are exactly the same. In other words, that they are congruent. Because if they're congruent, then it means that all their corresponding sides and angles will be equal. Emphasis on the angles. So it would mean that this angle is equal to this angle, and this angle is equal to this angle. And then these two angles would be equal. And then when we get to this point, we'll be able to show them that each angle is 90 degrees. Okay, so let's go ahead and start proving. So let's introduce the triangles. We're introducing the triangles AOD and BOD. So in triangle AOD and BOD, and we can focus on the sides that are equal because we don't really have any angles that we can prove are equal. So first notice that OA is from the center to the circumference, and so is OB. So they're both radii. So we can say that OA equals OB, and the reason for that is radii. Okay, they are radiuses of the circle. Then we have OD, which is a shared side. So of course it's going to be equal to OD in the other triangle, and we can say shared side. And then we have one more side that is equal. They already told us that AD and BD were equal, so we can tell them that AD is equal to BD, and this is because it was given. So it's given. Okay, it's a given side. So this concludes that triangle AOD is indeed congruent to triangle BOD because we have three sets of equal sides. Three corresponding sides are equal in each triangle. Now, what that concludes is, because these two are congruent, it would also conclude that these two angles, this angle is equal to this angle. So let's just put it like that. But we'll call it ODA or ADO, that's fine, and BDO. So we're saying that those two are equal. So angle ADO equals BDO, and the reason for that is because we had congruent triangles that we proved. Now, they are equal, but that doesn't already conclude that they're equal to 90 degrees each. How we can prove that they're equal to 90 degrees is that they lie on a straight line. So these are exactly the same angles. What if they were called x, right? If you add these two and they have to add up to 180 degrees because they lie on a straight line, then this has to be 90 degrees and that has to be 90 degrees for them to be equal. Okay, so that is the idea behind it. So we can tell them that ADO, angle ADO, plus angle BDO, that they add up to 180 degrees because they are angles on a straight line. Okay, and because we know that they're exactly the same, look at what we can do. We can update this equation. So we can go ADO plus, and then in place of BDO, we can replace that with ADO since they're exactly the same. It's equal to 180 degrees. And then this makes up 2ADO, which is equal to 180 degrees. And if we divide both hand sides by 2, then finally angle ADO is equal to 90 degrees. And since that's equal to 90 degrees, then BDO is also equal to 90 degrees. So they're both equal to 90 degrees. And if they're both equal to 90 degrees, then that would conclude that line OD really is perpendicular to AB. So there's our conclusion. So therefore, OD is perpendicular to AB, and that is how we prove that theorem. Question 9.2 says, in the diagram, E, B, F, S, and P are points on the circle centered at O. GB is a tangent to the circle at B, and then we have that FE is produced to meet the tangent at G, and then OT is drawn such that T is the midpoint of EF. GO and BO are drawn, and BS is drawn through T. And lastly, we're told that PS is parallel to GF. So the first question, 9.2.1 says, prove given reasons that OTBG is a cyclic quadrilateral. So let's see what they are referring to. OTGB is this over here. So we have to prove that this is a cyclic quadrilateral. Okay, so it would mean that it would be within its own circle. There are 3 theorems that we can use to prove that a shape is a cyclic quadrilateral. The first theorem is if we have some sort of quad in a circle, and you notice that the exterior angle of this quad is equal to the opposite interior angle, then it means that this is a cyclic quad. The second way to prove that a shape is a cyclic quad is if we have a quad inside a circle, and you notice that the opposite angles of these quads add up to 180 degrees, then this is a cyclic quad. And then the third way to prove that a shape is a cyclic quad is if you have this situation where you could have a chord or an arc, and you notice that there are angles at the circumference, and those angles are equal, then this is a cyclic quad. So based on the diagram that we have to look at what would best suit these scenarios. Now, already looking at this, I see that it has lines going across. So let's try to see if it is this situation over here. Okay, so looking at this and looking at what we know about the angles at the circumference. So you can look at it in different directions. You can look at maybe this angle is equal to, and let's use a different color. Maybe this angle is equal to this angle. But for now, I don't really see these angles traveling anywhere. So then we could look at it as maybe this angle over here is equal to this angle. This one is specifically at the center, but I can't seem to move that one either. So we could also just focus on these 2 angles. And let's just see, based on where they are, this one is between a tangent. And do you see that they said that OT was drawn such that T is the midpoint of EF, okay? So if T is the midpoint, and I'm going to have to remove this because it's going to just distract. If T is the midpoint of EF, then we can see that the previous theorem we just worked on, that proof, is showing up here. We have a line from the center of the circle to the midpoint of a chord, okay? And that line would be perpendicular to the chord. So that is 90 degrees over there. Now, if this is 90 degrees and we're trying to show them that the angles in the same segment are equal, then this should be 90 degrees. Can we see how that is 90 degrees? Well, yes, because this from O to B is a radius, okay? That is the radius, and this is a tangent. The angle between a tangent and a radius is 90 degrees, okay? The tangent is always perpendicular to the radius at the point of contact. So we can see that this is the angles in the same segments that we have over here. See, those 2 lines cross like that, and so that angle is equal to this angle. Okay, so let's go ahead and find those individually. We're going to tell them that OTG is equal to 90 degrees, and that is because of the line from the center to the midpoint of the chord. And then we also know that OBG is also 90 degrees, and that's because the tangent and the radius are always perpendicular at the point of contact. So OBG is also equal to 90 degrees because of tangent perpendicular to radius. And so we can conclude that these two are equal. So that concludes that OTG is therefore equal to angle OBG. And so that would prove that that is a cyclic chord because we had angles in the same segment that were equal. So OTBG is a cyclic chord. And the reason we can actually give is it's the converse of that theorem. So we'll tell them it's the converse of angles in the same segment. Okay, and remember it is the converse because they didn't tell us that this was a cyclic chord. We had to prove to them that it's a cyclic chord. So because the angles in the same segment are equal, it is therefore a cyclic chord. Okay, and that is our answer. Moving on to the next question. Question 9.2.2 says that we have to prove that GOB is equal to S, angle S. Okay, so let's look at this. GOB is over here. So remember, everything we're doing now is with the knowledge that this shape is a cyclic chord now. So this is GOB, and we have to prove that it is equal to angle S. Okay, so how do we get from this point to this point? Well, this is a cyclic chord. So you see how these lines go across again? We can show them that GOB, this angle over here, is actually equal to, and you see that the lines go across like that, okay? So it would mean that the chord supporting this angle, that it is on the circumference of whatever circle it belongs to, okay? If there was a circle over there, then that actually proves that angle GOB is equal to this angle over here, which is angle, we can call it GTB or BTG. Okay, so those two would be equal. And then remember that we have parallel lines. So these two lines, if they are parallel, it means that we have corresponding angles. So that angle is actually equal to angle S. And that is why GOB would be equal to angle S. Okay, so let's just go GOB. We can start off there and say that angle GOB is equal to that angle over there, which is angle GTB. We can just call it GTB, that's fine. And the reason they are equal is because they are angles in the same segment, since there is a circle there and that shape is a cyclic chord. Okay, and then the angle GTB is equal to angle S because we have corresponding angles. It's an upside down F because of those parallel lines. Okay, and then we'll tell them corresponding angles and make sure to point out the lines that are parallel. Okay, because PS is parallel to GF as they said, and that would conclude, since they're both equal to angle GTB, that angle GOB is finally equal to angle S. And that is our answer. Question 10 says, in the diagram, PQRS is a cyclic quadrilateral. KP is a tangent to the circle at P. And then we have C and D are points on chords PQ and PS respectively. And CD is produced to meet RS at A. Then we are told that CA is parallel to QS and RC is drawn. And lastly, they give us an important piece of information, which is that angle P1 is equal to angle R2. Okay, and the first question is to prove, given reasons, that angle S1 is equal to angle T2. So let's see where these angles are first. So angle S1 is over here, and from where it is, you can see that it is the exterior angle of this cyclic chord. Okay, so we can use that property on that. And angle T2 is way over here. Okay, so remember the diagrams are not drawn to scale. They may not look like they're not equal, but they are definitely equal. Okay, let's see how we can form this. Can we move from here and then eventually move to here? Okay, if we try doing that immediately, just going from here, angle S1 would be equal to this angle, the opposite interior angle of this cyclic chord. And that's angle Q1 plus Q2. Now, how can Q1 plus Q2 be equal to angle T2? Okay, seeing that it's in such an awkward place, we can't just immediately make it directly equal to this. So it's probably a case that we're going to have to create equations and they will eventually be equal to angle T2. But you have to do this intentionally. Don't find random things. Don't say, oh, okay, I know that angle P1 is equal to angle R2. So I'm saying angle P1 is equal to angle Q1. But why? Okay, because now you're just moving from points to points with no actual direction. So here's a method that we can use. In order to prove this, we can focus on the main goals. The main point of this is to show that angle S1 is equal to T2. So we can focus on S1 and T2. Let's focus on forming equations that include S1 and T2 separately. Okay, with S1, it is quite simple because S1 it only looks like it can move in one place right now. Angle S1 is actually equal to angle Q1 plus angle Q2 because of that exterior angle of a cyclic-quad. And let's go ahead and put that down first. So angle S1 is equal to angle Q1 plus angle Q2, and it's because of the exterior angle of a cyclic-quad. Okay, and now that we have an equation for S1, or an equation that at least includes S1, let's focus on angle T2. How can we find an equation that would include angle T2? Okay, so looking at T2, there's the triangle. Not a good idea because then you're going to include an angle, an actual numerical angle, 180 degrees, okay? Angles in a triangle add up to 180 degrees. We don't want to look for things like that right now because you see the type of equation we have here. So how else can we form an equation with angle T2? Now, one thing about this is the diagrams are usually drawn in a way where they sometimes don't want you to look for specific angles. I can see these are opposite each other, okay, vertically opposite. But the reason I'm not even going to work with that is just because they didn't even try to name it. So it's probably not that important. So let's see. You see angle T2 is actually an exterior angle as well, but of a triangle. Wow, okay, and this triangle includes an important point that we know about, angle R2, which is equal to angle P1. But okay, we're focusing on this, okay, and it also includes angle Q2. So this is probably the way we'll find it. So we'll say angle T2 is equal to angle R2 plus angle Q2. Let's see. Angle T2 equals angle R2 plus angle Q2. And so that is because of the exterior angle of a triangle. Okay, so notice how these two are the exact same angle. That would mean that if we can show them that angle Q1 is equal to angle R2, not really just like show them, like force it, but it probably means that angle Q1 is actually equal to angle R2. And so because of that, these two would be equal. So let's focus on angle Q1 now and angle R2. So always focus on the angles in question, and then you'll be able to see what you need to prove from there onwards. Okay, so Q1 and R2, let's look at that. Angle Q1 is over here, and angle R2 is over here. Angle R2 is that one that can, it's also equal to angle P1. How is it equal to angle Q1? Okay, look at this. We've got a tangent and a chord. Remember how this is equal to P1? Look at P1. Let's focus on P1 since those ones are equal. So angle P1 lies between a tangent and a chord, so it would be equal to the angle supported by that same chord at the circumference. So angle P1 is actually equal to angle Q1. So there, angle P1 equals angle Q1, and this is because of the tan chord theorem. And now that we know that is equal, we also know that angle P1 is already equal to angle R2. They told us that. So look at what we can just tell them. But angle P1 is equal to angle R2. Okay, but we already knew that P1 equals angle R2, and that was given already. So here's the conclusion. Since Q1 is equal to P1 and R2 is equal to P1 as well, it means that angle Q1 really is equal to angle R2. And now we can actually update this. See how this one has Q2 and Q2? This one has Q1, and now we found that R2 is also Q1. So let's update this equation. So it means that angle T2 is actually equal to angle Q1 plus angle Q2. And so since that is equal to that, and angle S1 is also equal to angle Q1 plus angle Q2, then it therefore means that angle S1 is equal to angle T2. And that is our answer. Okay, question 10.2 says we need to prove, given reasons, that AD over AR is equal to AS over AC. So we can just highlight these lines in the triangle: AD, AR, AS, AC. So AD, AR, AS, and AC. You can see from that this includes two triangles. This bigger triangle, ARC, that triangle, and then the smaller triangle, ASD, this triangle over here. We can prove that those are similar. If we can prove that they are similar, we can use the dimensions and then get it to look like that. So let's see. How can these be similar? Well, firstly, they share a common angle. That is great. So we already have one angle equal in each triangle. Now, we already had stuff here. We already had angles being equal here. The other angle that we can choose in ASD would be angle S1. And the reason I'm choosing this is because we've already worked on this. We were able to prove that angle S1 was equal to angle T2 in the previous question. So remember that we are working on this bigger triangle and this smaller triangle. So we would have to prove that either one of that, angle T2 or angle S1, is equal to angle R1, or it could also be angle C2, because it's not always drawn in a way that the angles align. Okay, so do you see that angle T2, because these are parallel lines over here, this line is parallel to this line, so we have alternate angles. And so angle T2 is equal to angle C2. That is part of the bigger triangle ARC. So you see that you have those two angles equal in these two triangles. So by default, their third angles would also be equal. So let's go ahead and prove this. So we can introduce our triangles. Let's make sure we just name them properly. So we're going to name them in the way that they are similar. Okay, so this is triangle ASD. And the second triangle would be, also name it in the correct order. So if we went from ASD in this triangle, because we can see S1 and C2 are equal, it would be triangle ACR, like that. Okay, and let's go. So we know that angle A is equal to angle A because this is a common or a shared angle, okay? And then we also know now that angle S1 will eventually be equal to angle C2. And the reason was because those two were equal, and we can see that angle T2 is equal to angle C2. So let's state that first. Angle T2 is equal to angle C2 because of alternate angles. And just remember to state the lines that are parallel. They already stated them there. CA is parallel to QS, okay? So CA parallel to QS. Okay, so we've stated those lines that are parallel. And then we are concluding the two angles in those triangles that are therefore equal would be angle S1 and angle C2. But just to make it make sense, you can also just tell them, but we knew that angle S1 was equal to angle T2. So like this, we knew that, let's just say angle S1 was equal to angle T2, and this was already proven. So this now concludes that because they are both equal to angle T2, that angle S1 is equal to angle C2, like that. Okay, so those are the two angles in those two triangles that are equal. And so now we can finally conclude that the third angle by default in those two triangles would be equal. So the third angle is angle R1 and angle D1. Those are now by default equal. So angle R1 is equal to angle D1. And you can say the third angle in a triangle or the sum of angles in a triangle. And so by default, they are equal. Okay, so those are three angles in the triangle that are equal. And so therefore, triangle ASD is similar to triangle ACR. And it has to be named correctly. And this is because we have 3 corresponding equal angles. And now that we have proven that they are equal, we can use their dimensions. Make sure to focus on dimensions that you see here. So I see AD, so I'm going to take AD. And so I'll say AD over, and that has to correspond. I took the first and third letter, so first and third letter. So that's AR, okay, is equal to, so now I see AS over there, so I'm going to take AS. That's the first and second, so that's AS over first and second, AC. And there we go, okay? So we've proven that. And we can conclude this because we had similar triangles. And that is our answer. That is how we prove this. Question 10.3 says, we need to prove that AC times SD equals AR times TC. Now, with these questions, what they have over here usually has to do with the previous question. But let's go ahead and see the lines they're referring to. So AC, SD, AR, and TC. So AC, SD, AR, and TC. So it has the lines in the triangle that we previously proved. Okay, those 2 triangles where we proved that they are similar. So we can go in that direction. Let's go ahead and just look at the sides they're using and see whether they are in these triangles or not. So I'm focusing on this part where we showed that they were similar. We have AC. Do we have AC here? Yes, we do. Okay, so that would be paired with AS. So we can say AS over AC is equal to, and we don't really have AS here, but okay. And then what else do we have here? We also have SD, okay? So SD is also here. So that is SD over, and then that would have to go with CR. Second and third, so second and third, CR. And let's multiply. So when they multiply, they got AC and SD together because they cross multiply. So that's AC multiplied by SD is equal to, and then cross multiply, AS multiplied by CR. Okay, seeing that this started with A and came from the same point, we're just going to have to see in relation to that triangle or the triangles that we have there, what are these points? So do you see that in order to prove this, we already have the left-hand side. We would just have to show them that this part is equal to this part. So let's look at those lines and find out how is that even possible. How can AR times TC eventually be equal to AS times CR? So let's highlight AR, TC, AS, and CR. Okay, so that is AR, TC, AS, and CR. So that is what we have. Okay, so do you see now that we have parallel lines here? Okay, and they have clearly used the proportionality theorem. Okay, so we can go ahead and take AS over AR and say that this would be equal to, it has to correspond here, CT or TC over CR. Okay, because of the proportionality theorem. And this is because of the proportionality theorem. Okay, so since we're using this, we're going to have to state that this was because of the similar triangles that we had. And then we were able to conclude this. And so this is because of the proportionality theorem. Okay, so we have that. And now we just have to multiply it so that we can get this other side, AR and TC. Let's go. And then when we multiply, we might as well just put it on the left. So AR times TC, and then that is equal to AS times CR. So here's the thing. Because they are both equal to AS times CR, it would mean that they are equal. So now we can finally conclude that that means that AC multiplied by SD, that left-hand side, is equal to this right-hand side, AR times TC, since they are both equal to AS times CR. And that is exactly what they did as well. So, and that is how we prove that. And that is it for question 10. Okay, so that is the end of this paper. I hope you guys enjoyed it. Hope you have a lovely day ahead, and I will see you guys in the future videos.